Hello, good afternoon students. Today we are going to discuss about the previous year question of electronic measurement and measuring instruments. Okay, so I have already taught you in classroom, online platform. I think this discussion will help you to get better marks in your upcoming semester and also help you to understand what type of question you may get in your final exam. Okay, so this question paper and the necessary solutions and the study materials and also the book name and links etc are shared in your already shared in your Google Classroom. So all students are requested to follow strictly the Google Classroom. Okay, so many of you, I have noticed many of you uh, still not joined Google Classroom. So all students are requested to join the classroom immediately. So today I am basically discuss the broad type question, that is long answer type question. That is, you may see that this from this question paper, that is question number 7. Draw and explain the detail the shunt type ohm meter. So to understand the shunt type ohm meter, first you have to know the function of ohm meter. Okay, so please wait, I am sharing the study material. Okay, so you can see that is the ohm meter chapter. So your question is shunt type ohm meter. The question is discuss in detail shunt type ohm meter. So this is basically two type of ohm meter we know. That is, one is series type ohm meter and the shunt type ohm meter. Okay, so first of all we have to know what is ohm meter. So ohm meter is the measuring instrument through which we can measure the resistance. That is, the you know, all of you know the unit of the resistance is ohm. So from the unit name it is ohm meter. Okay, so through this you can easily measure the unknown resistance. And here how we can classify the series type ohm meter and shunt type ohm meter according to the connection of the meter with the unknown resistance. It may be series, it may be shunt. When it is in series, it is series type ohm meter. When it is shunt, it is shunt type ohm meter. So here we are not discussing series type ohm meter because my question is shunt type ohm meter. So today I am only discuss the shunt type ohm meter. You can see the circuit diagram of shunt type ohm meter. That is, there is a battery, there is a resistance R1, that is a variable resistance. There is a meter, you can see, that is the ohm meter. Rm, what is Rm? That is the internal resistance of the ohm meter. And there is a unknown resistance connected in parallel in shunt with the meter. And obviously there is a switch, you can see, that is switch to off or on, disconnect or connect the circuit. Okay, so it consists of the battery in series, adjustable resistance R1, and the movement, that is the meter movement is also known as Bierson movement. So here you have to find out the unknown resistance. Here the unknown resistance is connected. Suppose if you consider the terminal A and B, the unknown resistance is connected between A and B, and the necessary on-off switch is connected here. First you have to know about the calibration of the shunt type ohm meter. You can see here, that is here, right, dial of the shunt type ohm meter. Left hand side it is marking as 0 and extreme right there is infinite. So the meter is dial of the meter is moving from the 0 to the infinite. As the resistance increases, it goes to the infinite. So here to mark 0 ohm reading on the scale, terminal A and B should be shorted. So as we all know that when two terminals are shorted, obviously at the time the resistance is 0, right? So as we know that if terminal is shorted, there is no resistance, so all the current will be flowed through the wire. Short means we are just connect two terminals, suppose here A and B. Okay, the unknown resistance at the time, that is Rx equal to 0, and the current through the meter is also 0. It is bypassed by the short circuit. Okay, the meter, through the meter there will be no current, all the current will be bypassed through the path, that is through A and B. Okay, the pointer is marked as 0 ohm at that time. Okay, now similarly to mark infinite, what we have to do to mark the scale infinite, that is A and B terminals are opened, that is open circuit. Okay, to open the circuit we are getting a infinite resistance, that means the circuit will be on air, there is no current flow in the circuit. Okay, the circuit basically disconnected. Okay, and full current flows through the meter. If you can look the circuit, that is if A and B terminal is open circuited, that all the current will be flowed through the meter. In this position the pointer is marked as ohm, infinite ohm. That means in this case all the current will be flowed through the meter. So we are getting the pointer at the extreme right. Okay, clear? So intermediate marking can be done by connecting the known values of the resistor between A and B. Suppose we are discussing about the 0 ohm and the infinite ohm. What about the intermediate resistance? So intermediate resistance, suppose 100 ohm, suppose 1k, suppose 10k, whatever the resistance, it may be intermediate position depending on the range of the ohm meter. Obviously the range of the ohm meter will be different, and here we are getting the different resistance from the ohm meter. The shunt type ohm meter is particularly suited to the measurement of low value of the resistance, right? So when we are measuring low value resistance, we choose shunt type ohm meter. Hence it is used as a test instrument in the laboratory for special low resistance application. So from here we can also understand the application of the shunt type ohm meter, that is it should be in case of low resistance measurement. So in opposite case, in series type ohm meter, high resistance will be measured. But today I am not discussing about series type ohm meter, because we are only discussing about the shunt type ohm meter. Okay, I think this question is clear to you. So that is the shunt type. Next I am going to the question paper again. That is here the question paper, 1 minute. Next question is, give the classification of error and explain them. Errors. So I think that is the first chapter, error chapter, that is the qualities of measurement. That is also interesting chapter, that is the basic chapter. 1 minute. Qualities of measurement, and that is errors and the type of errors. Okay, so you can see that is the error in measurement. What is error basically? One, that is desired value, another is measured value. Now you have to understand what is desired value and what is measured value. Desired value that you expect, that is also known as expected value. Okay, and the measured value, that is you are getting after measurement. So if the expected value and measured value are different, then the difference between the expected value and the measured value is known as error. Very simple, that suppose you are expecting from a circuit, suppose there is an electrical circuit, you are expecting that from this circuit you are getting suppose 7 volt. At the output we are getting the 7 volt output. But when you are measuring with the help of voltmeter, you are getting 6.5 volt. So what will be the error? That is the difference between the expected value and the measured value. That is obviously here 7 minus 6.5, that is 0.5, that is the error. So here also the absolute error you can see from this, that is yn minus xn, that is the difference between that is E is the absolute error, and here expected value is yn and xn is the measured value. So from here we are just calculating the percentage error. You can see absolute value divided by expected value into 100, that is E by yn into 100, that is percentage error equal to yn minus xn divided by yn into 100. It is more frequently expressed and the accuracy. So here that is very closely connected between the accuracy, the term accuracy and the error closely connected, because the accuracy is the 1 minus error. So what is the error from the all total? If error is deducted, that is the accuracy. So if suppose in a system 5% error is occurred, then accuracy is 95%. So you can say this. So 100% minus percentage error, that is the accuracy. Now the question was what is error and about the types of error. Here we are discussing that is the types of error. Okay. Here short description of the types of error, that is gross error, systematic error. In between systematic error there is instrumental error, environmental error, observational error. Now we are going to the details of the errors. Now what is gross error? Gross error is also known as human error. So what is human error? Human error, suppose one instrument is used by several technician or the user, it may be technician or maybe the layman. So one who use or who measure the quantity through a device or instrument, if there is a error due to the human cause, that is anyone do not know how to use the instrument properly, there must be some error. If anyone asked you to measure a biological instrument, so it is quite natural you cannot do the proper measurement. So what is necessary? That is proper training or knowledge is required to use or to measure the instrument properly. So if any kind of error which is occurred due to the human mistake or human lack of knowledge, that is the gross error or human error. So that error cannot be mathematically calculated. This is not possible. So which kind of mistake I will do or you will do, that is no one knows. So you cannot eliminate this mathematically. So mathematically elimination is not possible. You can minimize the elimination, you can minimize the error by the getting the knowledge how to use the instrument or how to use the process. Okay. Next, systematic error. Systematic error is there is three type of systematic error. One is instrumental error, second one is environmental error, third one is observational error. Okay. So instrumentation error. What is instrumentation error? Instrumentation error are inherent in measuring instrument. Sometimes there is a error which is in between the instrument, that is the instrumentation error. So that is due to the error of the manufacturer, or sometimes after manufacturing, due to the aging effect of the instrument, it may occur. Okay, that is the instrumentation error. And next, that is the environmental error. What is environmental error? That is environmental error due to the condition externally inbuilt in the measuring device, that is such as temperature, humidity, biometric pressure, magnetic or electrical induction or electrical field. These kind of external hazards or external influence which affect the system or measurement, that is the environmental error. And third one, that is the observational error. That is, observational error is also is one kind of error, that is human error, that is due to the mistake of the human, that is how you can see, how you can observe the measurement, that is the observational error. Okay, and the last one, that is the random error. Random error, these kind of errors remaining after gross error and systematic error, right? So these errors are due to the unknown causes. Sometimes you cannot understand which kind of error is induced in the system. If there is no small effects, there is no gross error, there is no systematic error, so which kind of errors is there? So these kind of errors is called random error, and randomly it will gather in the system and damage the measurement. So all of you have to remember, that is that you should keep in mind that error should be minimum. If the system is 100%, so error may be up to 10%. Suppose, say, a good accurate measurement may be allowed up to 10%. So if you can see that error is 40% and accuracy is only 60%, that is the original data or the original information may be destroyed. So the data, after huge error you are getting, you cannot do anything with this information or with this data. So the error which is very important to reduce, and what is the process to eliminate the errors, you have to know. You have to carefully manage the measurement, that human error must be human error here. Human error is a very important phenomena, because you cannot mathematically treat it, because who one make which kind of mistake, that is not possible to know. So proper knowledge to how to measure the instrument with the instrument, that should be properly known. Okay, so I am discussing the broad question of the previous year, so I am not taking many more time in this video. In the next video I am discussing the next part of the experiment, next part of the question paper, sorry, not experiment, question paper, and here we are discussing the remaining broad question and also the short question of the question paper. So up to this I am ending here the video. Okay, thank you students. Wait for the next video. I will definitely share in the group, in the classroom. Okay, thank you all.